ladies and gentlemen, this is Ms. Dubois yet again trying to help our students through our Coronacation day number. I've lost track already, so early. Right now we're going to be talking about Algebra 1 Goal 4, and specifically we're going to be talking about word problems. Word problems are a thing that many students kind of struggle with. They're not quite sure how to read something, what to look for, and I kind of want to take some time to break it down. There aren't as many word problems as there are in other goals, but the good news is that the three critical ones you need, the ones that are DSA level of word problem, are actually relatively easy to break down. And again, order is important. So we're going to start particularly with interpreting the parameters of a linear function modeling a real-world solution. So let's scroll down and let's zoom in. This first topic for word problems, they're actually pretty nice to you in the sense that they give you the equation already. So looking at this one, scientists are studying temperature of a distant planet. Let y represent the temperature, so they tell you outright what your variables are. Let x represent the height above the surface in kilometers. Suppose that x and y are related by the equation blah blah blah. Answer the questions below. And here's the key thing that they're looking for here. What is the temperature change? Oops, let me do that again. What is the temperature change for each kilometer? That word right there, change, is the most important word there. I'm going to highlight it even more. Change is the most important thing that you are looking for. Whenever you're filling in this particular topic, change means your slope, which means it's the number with the x. Number with the x. Did I give myself enough space? There you go. Change equals slope equals the number with the x. So when we are looking here, what number is with our x? The -3. And that's how we're going to know what number it is we are using for this particular question. The next question, what is the temperature of the surface of the planet? That's your leftover remaining number, which in this case is 46 degrees Celsius. And that's the big thing. So long as you know which number the change is, you automatically know what number the equation is. And since they give you the equation every time, there's actually not a lot of thought related to this particular word problem. Be very careful where they find out where change is. For both of these screen grabs that I took from the software, rate of change was listed as the first one. They don't always do that to you in the software. So please, for the sake of your sanity, be very, very wary of that. All right, so again, Heather is a software saleswoman. Y represents her total pay. X represents the number of copies of a book, blah, 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 she sells. English is fun. Miss Leavenworth, they made that for you. Suppose that X and Y are related to the equation. So what is the change? Change, as we just noted up here, is your slope, so meaning that's the number with the X. What's the number with the X? 80. Done. Not even with any thought required. What's our leftover number for the total pay that she receives even if she sells nothing? 2,200, because that's the number that doesn't have a variable with it. So this topic, the interpreting the parameters, that's actually very, very straightforward. And as a confidence builder, that then leads us to the next one. So what are we going to be looking at next? Writing and evaluating a function that models real-world situation. Now here, instead of giving you the equation like they do up here, they expect you to write the equation. So the difference here now is that we have to keep track of our words. So let's make a little notes page. Our slope is going to be denoted by particular words. So for example, if you see per, or if you see for each, or if you see for every, the every, those are your words attached to slope. Your y-intercept has words like a starting amount or maybe a base price. Those are the things that you're kind of looking for when you're setting up your equations. So when we actually have those notes written down, so let's do some actual reading. Let's see here. Construction crew is lengthening the road. The road started with a length. There it is, right there. Started with, let me get my highlighter out. B. Where's my highlighter layer? Highlighter, where are you? There's my highlighter. All right, so we had there we go. Started with a length of 51 miles. Let me make that a little bit neater. Started with a length of 51 miles, and then it's 3 miles. Then it is 3 miles to the road each day. That gives us everything we need in order to write our equation. So we're left with y equals, what's our slope? 3x plus what's our base? What's our y-intercept? 51. And since we have this little cheat sheet for us, creating the equation actually doesn't become all that hard. The only thing left then is they're not actually asking for y and x, they tell you L and D. Knowing which is actually pretty straightforward. The L is the total length of the road. That's the dependent variable. You learned that in chapter 3. So that means L is always going to be our y. The first letter they give you is always going to be the y. So instead of 3x, it's 3d plus 51, excuse me. Next, what is the total length of the road after the road crew has worked for 37 days? All you have to do after that is they're telling you D for days, right? So it's just 3 times 37 plus 51. Let's do some quick math in our head. So that's going to be 90, 111, right? 3 times 30 is 90. 3 times 7 is 21. 90 and 21 is, 111 plus 51, and that's going to be 162. There's going to be our final answer. So the work itself actually isn't all that bad. Even though it's a word problem and that automatically sets the stress levels in your brain, once you know what you're looking for, it's actually pretty painless. So let's look again. Construction group 57. Look at that. It's the exact same thing, just with different numbers. And not even different numbers, because it started with a length of 57, and then you're adding 3 miles again. Oh my goodness. This is what happens when Ms. Dubois does not pay attention to the screen grabs. All right, so since we already know the setup from up here, let's see what we can do to paste in what we know. So y equals, what's our independent variable? What's our per, for each, and for every? It's going to be our 3. And then what's our base price? Our y-intercept is going to be 57. All right, only they don't want x and y, they want L and D. All right, and then what are they looking for the second answer box that they're giving us? They give us 38. So L equals 3 times 38. It's not even that much of a change. Plus 57. So let's do some quick math in our heads. 3 times 30 is 90. 3 times 8 is 24. Yeah, 24. So that's going to be 114 plus 57, which is 161.71 miles. All right, it's miles that they're using, right? Yeah, miles. Okay, next one. Let's see if this one's any different. Oh, it is, thank goodness. All right, so let's set ourselves up. Do I have enough space for there? Okay, so Sugar Sweet Company, da 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 da. Where's our highlighter? So what do we have? It will cost, highlighter, it will cost $7,500 to rent the trucks, okay, and then additional $175 for each ton of sugar. For each. Hey, I didn't even need to think about it. I found my computer. I found my slope. Let me try this again. There we go. So y equals, what's our slope? It is 175 for each, so 175 5x plus what's our base price? $7,500 to rent the trucks. And that makes sense. Before you actually add any ton of sugar, you have to rent the trucks at a base, and that's going to be $7,500. Okay, so far so good. Next, what's the first letter they give us to replace our y? It's C. So C equals 175. What's our x? S plus 7,500. And now we want to use 12 tons of sugar. Okay, 175 times 12, that's a little big for Ms. Dubois, so let's pull out the calculator. 175 times 12, so that's 2,100. So C equals 2100 plus the 7500. That's a little bit easier to do in my head. That's going to be $9,600. And that is how you do this particular topic. So 2 out of the 3 down. And again, even though they're word problems, the setup is very repetitive. Because you're only looking for key words, you're never overwhelmed, and then the work itself is not that hard. Now, this topic, when I tried to do screen grabs of it, they expect you to do graphing in this, and I could not get the graph to screen grab for whatever reason, not unless I went into the explanation and then the answer would be there, and then that would be boring. Where's the fun in that? So what we're going to do instead is I want to explain how this works in the software. First things first, we're going to make our equations. So let's see here. They are adding water at a rate of 25 liters per minute. So there's my variable, there's my x, and then there's 600 liters to start. So again, all of those keywords, per, for each, for every, start, and base, those are used here. So based on that, we then know what the equation is. W equals 25t plus, what's our start, 600. And I didn't even need to write my y equals mx plus b. I was able to jump right to the letters because after doing 3 examples of this, I'm pretty confident in how I'm doing this. The question then becomes, how do you make the graph? Because they're going to give you a graph, and then they're going to expect you to make your points. So what you're going to do is you're actually going to use, there is a little button that looks like a mini graph. It will have a little X in it. That's the button that you're going to be using when you're doing this, okay? So if you actually click that button, you'll be given the option to put in a coordinate. That's going to be to your advantage. So what coordinate then do you start with? The easiest coordinate of all, the y-intercept. That's 0, 600, because that's what this means. It's 600 without moving left or right at all, because that's where your y-intercept is, your y-axis. So then the next question is, what will your next point be? Well, if we're adding 625 for every ton of sugar, if we're going over, effectively up 25 over 1. We can actually do that with the coordinate that's given. We're going over 1, and then we're going up 25. So 6 plus 25 is 625. That's the part where some kids take a little bit of time getting themselves used to. So take a minute to read the problem so I can take a sip of water. All right, so let's look at what we're doing over here. Before we do, let's pull out our highlighter. What do we have? We have, let's see here, surface temperature at one location is 40 degrees Celsius. That doesn't have any keywords, so I'm not quite sure where that goes, but put that on pause. The temperature decreases, and they even italicize that. If they give you that italics, then you know it's something important. It decreases by 3 degrees Celsius for each. Oh, there it is, for each. I know what to do. All right, so what do we have? We have T equals, we're decreasing by 3, so negative 3 for the Celsius, and then therefore the 40 must be our base price, or excuse me, our base temperature. From there, we're going to be using this button in the software to put in some coordinates. So what is the first coordinate we have? We have the y-intercept, which is 0, 40. Let's see here, and then what's our coordinate after that? If we go rise over run, right? So we're going down 3 over 1. So we're going down 3 from the 40. 40 minus 3 is 37. 37, not that I can type. Once I put that into the calculator, I'll have 2 dots, and that will be enough for me to make the line. Next and last problem of the video. Let's see here. T represents the temperature. Let's see here. Find the surface in one location. The temperature decreases by 5 degrees, and then our base temperature is 45. I'm not even highlighting anymore because I've gotten to the point now where I know where to look for my information. And because I know what my letters are, and because I know what keywords I'm looking for, I can almost do this without thinking too much. but I understand for students, that might take a little while and you're trying to get comfortable with it. And then what are our coordinates? Our base is going to be 45, and then since we're decreasing every time we go over 1, we're going down by 5 units, so our next coordinate would be 40. 2 dots, connect the dots, make a line, and you're done. So that is everything for word problems in Goal 4 of Algebra 1. Goal 4 of Algebra 1. The next video I put upload, which will be, today's Friday, so the next video that I upload will be Monday. We'll be talking about linear inequalities, and that should be basically all the core topics covered for Goal 4. So anything else after my upload on Monday will be single topics requested by students. In the meantime, stay happy, stay healthy. Rumor has it it's going to be 70 degrees today. You might be able to open up your windows. See you in the next one.